So I just want to start off by saying I'm surprised at how many of you there are in the room. So it makes me want to ask, like maybe it's just morbid curiosity from the title because everyone wants to hear about like the car that crashed on the freeway. But raise your hand. Have you worked with what you'd consider like classical ML or traditional ML before at any point in your career? Okay. Nice. That's a decent number. Okay. And I wonder if you have felt like this conference has been extremely agentically oriented and there's not a lot of Yeah. Okay. Great. So my talk will have nothing to do with agents, so that'll be great. Actually, you don't even know what it means to me that there's that many people clapping. So. Okay, I'm going to introduce myself. So my name is Eric Riddoch. I've been working for about 7 years. I went to Brigham Young University in Utah, and I studied applied math, and I really struggled to get my first job. Like the transition from math to anything was just really rough. And so I thought I was going to be a data scientist, and the best I could get was being a lowly business analyst. So I learned SQL and made dashboards, and that was that career moment where you learn that 80% of data's value is like in simple statistics, like counting the number of things you sold. And anyway, so after that, I had been a data engineer as well, and MLOps was such a cool term, and I wanted to go be part of MLOps. And so there's a company called Ben Labs, which I'll tell you a little bit about, that they had a cool MLOps team, and they invited me to come work there, and that was a sweet career move, because then I was in MLOps from data engineering, which is what I wanted to do. Actually, no, I wanted to be a data scientist, but they didn't have an opening. They had an MLOps opening, and it's just funny because I'm just obsessed, and that's been my career ever since. But what Ben Labs does, like, I don't know if you've seen Into the Spider-Verse with Miles Morales. So like, he's the Black Spider-Man. So he meets all these other Spider-Man in the multiverse, and there's this one Spider-Girl who's like wearing this VR headset, and she's eating a bag of Fritos. So Ben Labs actually placed those Fritos in Into the Spider-Verse. And if you've seen Transformers, like we're the reason that Bumblebee is a Chevy Camaro. Like we have Bumblebee the Camaro like in a warehouse in LA. We're the reason that Barbie drove a pink car, Tom Cruise wears Ray-Bans. So we've done a lot of product placement. But we also had a Chrome extension to help YouTubers grow their channel on YouTube. And we had 14 million YouTubers that used that at some point. I don't know if they were monthly active users. I don't remember. But 14 million people using our Chrome extension. And I worked on some of the AI features with this Chrome extension here. So like this one that I popped up on the screen, it's a bunch of YouTube thumbnails, like slightly different variants. And we had like an image regression model that would like regress on the click-through rate. We'd like guess what the click-through rate of a thumbnail variant would be. And we'd like rank them in order of like what our model thought was best or worst. And then we could like help you run an A/B test with thumbnail variants. So we built an awesome platform, in my humble opinion. Maybe it's not humble, but it was great. And we went and presented about it in March last year at Netflix's Machine Learning Infrastructure Conference. And it was really good we did that, because right after that, there were mass layoffs at Ben Labs. So like the prestige from like that presentation really helped like get my next job. I had made a Udemy course, because I think there's like this age-old problem of like data scientists are statisticians, they're not software engineers. And so they do things like commit models directly to Git. And I don't know, just like that there's this handoff process, and because of their lack of engineering background, it can be difficult to collaborate with them. So I'd made a Udemy course out of frustration working with my coworkers about like, engineering practices for data scientists. And I'd wanted to make more, and so I took a break between jobs to like make some more courses in the vein of MLOps. And then I started a little over a year ago at Pattern. Pattern is the biggest seller on Amazon besides Amazon themselves. And I'm their director of ML platform. And basically Pattern runs e-commerce for people. So if you think about like, why is it that when I order the new Nintendo Switch 2, it can get to me within a day? It's because there are Nintendo Switch 2s in warehouses close to where I live. And so we'll do like demand forecasting, for example, for a ton of different products to say like, how many Switch 2s should we order to the Lehigh, Utah warehouse on Christmas Eve? And we also have, there's more use cases, and some of the epic fails revolve around that. So I'll get more into that later. But anyway, so it's been a very fun career, and now that you know my history, you have enough context for some of the fails, some of the insights. Okay, so good. I'm doing pretty good on time. So my first company, I was a data engineer, and I think in 2018 era there were like a lot of companies that had this team topology set up, and so like you'd have like a data science team and like a data engineering team. And the data scientists would go off on their own, and they'd do some sort of like POC, and they would then hand off that POC to someone else to go like harden and deploy and all that. Right, so there's a handoff, they say good luck, and then it's up to the data engineers to like monitor and deploy and update this thing. And that always goes great when you're saddled with maintenance and updating of a thing that you did not create, and so like it took us, what we were doing at the time, we would take people's CRM like Salesforce and HubSpot, and we would just basically score like how likely we thought someone was to pick up the phone if you called them. That was like this feature, and it took us 18 months to ship that feature, and guess what, it flopped. And like 18 months later, no one really, because if you think about it, it's like, okay, you just told me that this guy's like a 96 score to pick up the phone. Like, what does that mean? Is he going to pick up the phone? Is that like 96% of the time? Like, there was no explainability for the users. Like, what does the number 96 mean? Anyway, and so it just flopped because users didn't get it. They didn't trust it. Like, we're like selling to sales reps basically. And I was just thinking, like, we could have failed so much faster. Like, maybe if we had gotten some prototype out in like a week or something, we could have identified 18 months earlier that this was never going to go anywhere. Anyway, so this is like the classic working relationship with handoffs. So you got your data scientist who's like, hey, can you please turn this POC script into a data pipeline? Actually, can you update that pipeline? Actually, can you make it into a REST API or like a DAG? Can you do it again? We just switched from like PyTorch to TensorFlow. How's it doing? What do you mean the output doesn't make sense? Can you explain why it's broken? How long has it been broken? Can you make this more performant? And then the engineers will say, sure, but can you document how this works? I'm not a scientist. Can you stop committing models and CSVs directly to Git? Can you solve dependency hell for me? Stop bothering me, I have other teams to support. Explain why it's broken. You make this more performant. Which is funny, because if you think about it, it's like, what makes let's say we're talking about like a model serving endpoint. Like, what makes that thing broken? Is it slow? Is the latency slow? What if the latency is slow? Do you up the size of the instances, or do you choose a simpler algorithm to make it less slow? It's like, maybe there's something that like an ops person should do there, or maybe there's something that a data scientist should do there. And if you have two different groups owning it, it's like, that just slows down the iteration cycles of things you can try. So here's an idea. What if we stopped having data engineers or ops people deploy and maintain AI products, and we made the data scientists do it? And yeah, like you could have these like unicorn people you could find, like they just have to be experts at like everything. And you could find these people. Like, I mean, I want to be one of these people someday, and hopefully I'll make a lot of money if that happens. Yeah, they'll just be really expensive. So. And before I switched to this company, Ben Labs, the CTO sent me this article. Like, Stitch Fix used to be like the company when we talked about like MLOps and ML platforms and stuff. And it's funny because like, I don't know, they kind of went the way of Ben Labs, I feel like, where they had this great team and now it's gone. But there's a lot of learnings that came from their team. And one of the leads of the team put out this article where he was like, what do I love to do at work? And he's like, data scientists tend to love like the vertically facing business-oriented problem, like making customer churn lower or regressing on thumbnails to help YouTubers do A/B tests, or I'm trying to think, like demand forecasting the Nintendo Switch, to make e-commerce better. And honestly, as an engineer, like my eyes often glaze over when those conversations happen, and I'm more interested in like abstractions and tools and infrastructure and stuff like that. And I think it's cool if like my little module I made is like reused in multiple places. So yeah, I mean, I'm obviously profiling people, but I think it's a fair generalization that many data scientists enjoy the end-to-end thing, and many ops people enjoy like the ops thing. So what if you change the team topology to like match that better? So Vila and Savin from Outer Bounds, they had this like famous it's kind of like a Maslow's hierarchy of needs sort of thing for data science. And on the left, how much does an AI or ML developer care about modeling, deployment, versioning, orchestration? And then as you go down, how much infrastructure is needed for that? Defining MLOps. MLOps, in my mind, it's getting inferences to customer faster, better quality, cheaper. And an ML platform is a set of tools and workflows that is supposed to make that easy. It could just be all workflows, not tools. But anyway, so the idea is there's a significant difference between building something from scratch and operating an already built thing. So what if you could make the ops part of the problem so easy that like even a data scientist could do it? And really I just mean like they could do it without it consuming their whole job. Because you could have platform engineers build this thing, and then data scientists, they could own their own deployments, and then they know how to monitor it and update it. So what this does is it allows data scientists to like do the whole iteration cycle themselves, and not have it consume their whole job. And I actually think they prefer this. I mean, people will rebel. Like there are data scientists where all they want to do is fit XGBoost in a notebook. But there are many data, I don't think the reason most of us got into software was to because our dream job was to tweak IAM roles all day. Like most of us imagined showing our family this cool app that we made. Like, hey, look what I did. Here's this thumbnail analyzer for Mr. Beast or something. And so a lot of people actually do like to own their own thing end to end, like the monitoring and the self-serving and the deployment and all that, because it's fun. There's variety and stuff. It wasn't realistic back when that required a whole extra tool set. So maybe you can simplify it. Let's see, we're doing pretty decent on time. So the epic fail number one is just not having this. We just did handoffs. So that was the epic fail. And so it took us 18 months to get started. It would be better if you had maybe a self-serve model, you could fail fast and the data scientist could do a POC quickly. And hey, that's true of AI stuff too. I mean, I think when that stat that's going around LinkedIn about how 95% of AI projects fail, it's yeah, where have we heard that before? The data science people, anyway, because data science projects would fail all the time. And hey, maybe the AI bubble it's a misuse of AI bubble. It's not that the technology is fundamentally useless. It is useful. There are some code auto-completion tools that are fantastic, but the bubble is maybe using it in the wrong ways. And how do you not use things in the wrong ways? Maybe you do POCs and fail fast. So I mean, there's definitely some overlap there as far as having people own their own POCs end to end. All right, so what is inside of an ML platform? The cool idea, you could self-serve, but how do you actually what's in this box? Not much. It's funny because by now this picture is old, but back in the day, in 2024 at this conference, this is such an epic slide. But what's really funny is coming to this conference this year, you see Aporia by Coralogix, or what's another one? I'm blanking, but so many of these companies that were on this list are either gone this year or they've been acquired by someone else. We are totally in an era of consolidation. And it's funny because going up and talking to some of these vendors at this conference, I went up and I was like, hey, can you show me a demo of how you monitor a classification model or something? And they were like, no. Which, I don't know, just shows kind of where the industry is currently pivoted to. But anyway, so this has always been overwhelming. It's less overwhelming today because there's fewer choice. Unfortunately, I would say that the MLOps toolscape still kind of sucks. But the ZenML guys, they changed the way I thought about navigating the toolscape, and they basically said all of these tools can sort of be categorized into solving one of 13 jobs to be done. And a lot of tools do multiple jobs to be done. If you go grab SageMaker has an answer for training and serving and maybe a model registry, and maybe it's not the best at any one of those things, but that's kind of where, if you think about things this way as a set of jobs to be done, you can maybe start with a baseline that addresses whichever jobs you actually have, and then swap out components. As you need a more specialized experiment tracker, awesome. CommitML is still a tool that is good at that. Anyway, this is a generic architecture diagram. There's not much this is the diagram version of this table. A platform could be I have a laptop, and maybe I submit training jobs and batch inference jobs to some sort of offline system. That could be SageMaker pipelines, could be Vertex AI, Kubeflow pipelines. And then here's the model store here. Here's where Git goes. Over here is like maybe online inference endpoints, and maybe you have like an observability system. So I mean, we could look more closely at this, but the point is like, these things can be categorized into like one or more problems, and you may not actually have all these problems. So this slide just kind of shows, like, I went through each one, like here's the orchestrator, and you see a lot of these names here today, like Flight, Union, Valahai is here, Metaflow, Outer Bounds is here, ZML is here, like, so like a lot of these guys very nicely take care of like this orchestration piece, and some of them, like where I work right now, we're using Metaflow, and Metaflow I would say has a passable like model store and experiment tracker as well, like, so like in terms of like spikiness, like some of them do everything but aren't the best, and some of them like are a sharp knife for one thing. So, okay, let's see. So epic fail number 2. Well, actually, I'm gonna skip to the end because I think this one's the most fun, and if we have time, then we'll come back. But so this is maybe the biggest fail, and it kind of involves like 2 fails at once. But so it's like, okay, so there's this idea that you could like make an ML platform, and the point is to speed you up, right? If you have an ML platform, you can go faster. If you go faster, you can make more stuff. And so this little arc of the talk is like the consequence of that if you don't like get ahead of yourself. So, okay, so in data systems, failures are usually silent. And I think this is something that a lot of people don't understand. Like, several months ago, my company, we lost a large amount of money in a weekend. It was like $250,000. And it happened overnight. And essentially what happened was we were bidding on keywords on like an e-commerce site. And there was a data quality issue. And it looked like there were some keywords, and it looked like they had an 80% ROI instead of a 0.8% ROI. And so our pipelines were like, yeah, like just like, it blew a whole bunch of money really fast on some bets that were not good bets, and we just lost a lot of money really fast. And so actually there's a hot take that comes out of that story, which is like, honestly, there's a lot of like monitoring tools, like the Arises and Apurias of the world that like help you set up a dashboard. They're kind of like a Tableau, but they have some pre-baked like ML metrics like F1 scores and stuff. And it's like, those are useful, but honestly, to date, every single ML outage that I've ever experienced was actually always a data quality issue. It's something more in the realm of like great expectations or evidently AI, just like kind of assertions checking like, are there nulls in this column? Because there really shouldn't be. Like, anyway, and that example right there was a silent failure, because like, if the pipeline had crashed when it thought that the keywords were 80% ROI, that actually would have been a great outcome. Like, I think we would love to take that decision back and not make bets on those keywords, but it didn't crash, it just ran, and the output was bad. And so, especially in data systems, like, the biggest risk, I'd say, is often not a system going down, it's a bad decision being made. So, and just imagine if we did what some have suggested and we moved that pipeline to like some sort of agentic betting system, like, that's not explainable. Anyway, so I ripped this slide from a Datadog talk, but they had this Airbnb clone here, and you can see it like lists some hotels on the front page. And here, look at this on the front page. This is like their Discover feature, like top listings they're recommending to people. They're recommending like 2-star places. Like, are they safe? Do they have bugs? I don't know. But like, if you're showing up on the landing page of something like Airbnb.com and this is what they're showing you, like, you're probably losing a lot of money. And it's not down, it's just bad. So this is how it happens, and this is how it happened at a previous company where I was. Like, we built this platform, and we could make pipelines so fast. And so like when our team first started, like Databricks and Snowflake weren't as established, and so we just decided to go with like an RDS Postgres instance for our data warehouse. And you could argue if that was a good idea or not. I actually think it was a decent decision at the time. But anyway, so we made our first AI feature to help serve some internal customers, and it was a Streamlit app. Like, it was like people in the company were making these like big decisions based on the Streamlit app. And so what we did is we had like a data pipeline that ingested some data into our warehouse, and the Streamlit app would like visualize it. It was great. And then we wanted to add some intelligence to it, so we added like an ML pipeline using our platform because it was fast. And so we spun up this ML pipeline, and this pipeline, you can imagine like taking this clean data from table 1 and putting some inferences in table 2, and then it's like consumed by like another app of some kind. That's like such a common pattern. And you do that, and it's fast, and it works, and the next thing you know, you got like tons of pipelines and tables and UIs and dashboards. If you were a product manager at that company at the time and you wanted to get your feature in, like what you would do is you'd say, we need to. You'd basically coerce engineers to like go make a pipeline that would just write to a new table. Even if there was already a table that maybe had that thing or did that thing, like no, you just like start from scratch because it's such a tangled, undiscoverable mess that it's like way more time to like go sift through all this than it is to like just make a duplicate thing. And so this is actually like a DAG here. It's hard to see, but like there's pipelines that they eat some data and they produce some data and they go back and forth, and then there's some UIs at the end of this thing. And what was funny was our biggest expense at that company wasn't GPUs and it wasn't vendors. Well, I mean, unless AWS is a vendor, it was this RDS instance. Like it was costing us like $200K or more a year on this one instance. And so what would happen was, like the database would constantly like run out of memory or run out of storage. And like, let's see, how are we doing on time? Pretty decent. So it'd run out of memory, run out of storage. And it's like, do you up the size of the database or do you finally untangle the whole mess that's been there for like years? And it's like, you up the size of the database. So it just kept happening. And we wanted to move to like a more modern data lakehouse. We did like Databricks and Delta Lake, but it was like, how do you even move? Like what order do you move these things in to the new system to like not break the old one? And it's like, okay, you could like maybe move this table, but it might get out of date if you don't move the pipeline too. But like this UI over here is like using it, so it's like you got to change the client to like point to the new table. And so I actually came to realize that tables are actually kind of like microservices. Like the definition of prod is that customers are consuming it. And I think we all think of like APIs as like in prod or not in prod, but tables, if they're consumed to make like decide how much you're going to bid on like keywords with like a $250,000 decision, I would argue that's prod. And so there's all these. So it was really funny because like the open telemetry people were like, well, have you tried tracing? And it was like, here's our trace map. Like, if you know about tracing, which maybe you do from the agentic world, like it kind of shows what microservice is hitting what other microservice. And so it's like, okay, we have all these pipelines, and yes, they are hitting the lakehouse. But there's nothing about like ordering here. And so if you didn't know, open telemetry is for services and microservices. What open lineage is for data sets and pipelines. So here's open telemetry, a bunch of clients you can instrument, send the data to like a bunch of different observability backends. Same with, I don't have the open lineage. Same with open lineage, same thing. Like it's an SDK, instrument your SQL queries wherever you're making them, and you get this. Like the correlation IDs in OpenTelemetry are actually like the tables or the S3 assets or like whatever the data assets are. So if you look at a table, it shows you everything upstream and everything downstream, including like, this isn't a DAG because there's like cycles here. Like sometimes pipelines are cyclical. Anyway, so imagine you're going to release a change to a sensitive pipeline, and you wonder, is this going to break anything important? And like, if you're Elon with Doge, you probably just shut it off and see who screams. If you wanted to be a little more like sophisticated, it would be nice if you knew the blast radius. Like, who do I actually need to reach out to ask? And that's like one of the biggest things about the lineage question is like, if you get lineage, like even the dashboards, even the widgets in the dashboards, you can actually trace that back to the data source and who provides that. Anyway, so perfect for a migration scenario, perfect for like making a safe change scenario, like limiting your blast radius. Great for like discovering data that already exists. Anyway, so there's a whole bunch of backends. We did a POC with DataHub, which is open source. Acral Data, I think, is like the parent managing, you can get DataHub Cloud basically, but they have like a Helm chart. Not that I'm advocating that anyone use Kubernetes, but like they have it, and you can spin up DataHub. And here's this DAG. You don't really need to see. It's a machine learning thing on the New York City taxi data set. So here's a little Airflow icon here, and this is supposed to be Metaflow, but DataHub didn't have the Metaflow icon, so I just grabbed SageMaker. But like you can see, there's all these different data sets. But there's even all these different tools interacting with the data sets. So anyway, like there are solutions now for like OpenTelemetry was so big and is extra big now because of like tracing with LLMs and stuff. And I don't know, I think the hype isn't really as big for open lineage, but man, the people who work in data, we are all over that, man. So here's a fun thing. You can register, like, if you have like great expectations or something that does assertions, you can say, raise an error if there's any nulls in this column. So you can like create these assertions, these like data tests, and in the UI, or in many UIs and many tools, you can like see if they're failing or not. And you can know who to alert. You can automatically be alerted if you're like downstream of that. So that's sick. Let's see. So I got like 4 minutes. I think I'll do one more. Okay, here's the story of how our dev account became prod. So we had 2 AWS accounts, and we were like, this one's prod and this one's dev, and you have lots of freedom in dev, but in prod, there's more restrictions and stuff. And so what data scientists would do in this beautiful place where they could deploy their own stuff is they would deploy these like services, pipelines, Streamlit apps into dev because they had fewer restrictions. And then they would go to some internal group and like validate the idea. They'd be like, hey, does this work? And the internal group would be like, yes, it does. And then they'd start depending on it. And now you have like dependencies on something in the dev account, which is like a total disaster. And that's the story of how dev became prod. And so like I explained multiple times to people in the company, new people in the company, security people in the company, like, don't you mean deploy that to prod? And I was like, yes, it's dev. They'd ask why we're deploying to dev because dev was prod. Anyway, the way to not let that happen is maybe just routinely clean up dev like every week or something so that you can't form long-term dependencies. And I think the same is true of SQL tables, actually. So here's like one way we did dev versus prod in like Snowflake. So we had a prod schema and a non-prod schema. And if you are a dev pipeline, it means you only have access to write to non-prod. And so if you write to non-prod, that's cool. You can do it as much as you want, but your table is going to be deleted after 7 days. So that was the way we basically you're in prod if you have the ability to write somewhere your table is going to stick around or somewhere your service is going to stick around. Anyway, so that was a big thing. There's more. Template cookie cutter facilitates code duplication at scale. We had 100 projects more created from a cookie cutter template. And then one day we're like, we want to be able to pip install a private package. And we had to go change Docker files in 100 projects that had diverged in 100 different ways. And I realized like cookie cutter basically says like, here's these reams of code and boilerplate that I made for you. Now you own it. So there's these templating tools like Progen. Copier is kind of in that vein too, that let you make updatable templates. So that was a big thing. I think I'll stop there and just take questions for a bit. But yeah, that's the talk. Thanks for coming, guys. Hey, there's this QR code will take you to a Google Doc with if you want to, I've given some talks on each of these things, more long form, 90 minutes or so. So if you want to go learn about any one of these things, you can go there, so.
I'm just curious, how many of these fails are a result of just bad engineering or architectural design?
How many of the fails? Well, it's funny because we've done in my career, it's been 5 iterations of platforms, and each one was better than the last. And so it was I thought we were good engineers because connecting to VPNs was always terrible. And then we found this way in the next platform not to have to connect to a VPN, and it was that was great. But then there would be new problems that were unsolved. The lineage thing, I just never thought about the day when we have 100 projects. So, I mean, I like to think that we were good engineers who could solve problems. We just didn't have enough imagination to predict what would happen. Anyway, so.
I didn't quite understand the cookie cutter thing, but I do understand the problem. Have you guys thought about using UV and just a base Docker image? Because that totally blew my mind and my workflow.
That is amazing. We could totally have a conversation about base images, base image management. But because if you think about it, if you have a repo and you want to have CI/CD that deploys to dev and CI/CD that deploys to prod, and maybe a Docker image that has a step that lets you pip install internal dependencies, so here's an example. We were doing all of our CI steps serially. First we would lint, and then we would test, and then we would deploy. And we had this idea, wait a second, what if we parallelized all those? Because you can lint and test at the same time. But it was too late. We'd already created the YAML files and put them in all the repos. And so this is more aimed at that use case of treating your boilerplate code as like an abstraction and being able to like roll out changes to all of those already generated files. So anyway, so like I would say what you said about using UV in a Docker base image is like something I would like to do, and if I wanted to like vend that solution to all these existing projects, I could use something like an updatable template to like put it in, like magic it into everyone's projects. Like, yeah, I love it. What else? There are no stupid questions, by the way, so. Yeah, please.
So this touched on the first question touched on the architecture thing. You know, I'll put on my prima donna ivory tower architect hat, okay? Like the first epic fail that you described, I watched it, I'm like, well, this is a page out of The Pragmatic Programmer, if you will, and about separating what your users, in this case, the data scientists, what they need to do and making that an input to the system, which you got with the ML platform. So my question for you really is, if you look back on it all, and let's say that you got called into a meeting and said, you're now an architect, what would you do differently with all these systems, knowing what you know now? Now that you have the battle scars now, right? And I hear that.
Yeah, I mean, I think what vendors are good at is theoretically they've seen a lot of use cases and they've seen a lot of pain points. And so when you talk to like Vila and Savin or like Hamza and Adam at ZenML or Outer Bounds, like you're hoping that they have seen people that were at where you're at, and they can like, the most valuable thing they can give you, I think, isn't their tool actually. It's like telling you, it's predicting the future, like all these ways that can go wrong. So like now that I know about these problems that you have, I would recommend an ML platform for just any data science team with like more than 2 people, like more than 2 data scientists. So I think that was like the first thing. And it was funny because in our most recent iteration, I think it's the simplest it's ever been. We're down to like 1 vendor and like, they're like sort of a sharp knife. Like we're using Outer Bounds. But we're using like very standard tools like UV, VS Code, whatever. And it's funny because even UV and VS Code were like a big learning curve for people. And so like the most recent problem we've this was always an issue, but like the biggest issue today is like it's still more complex than I want it to be for the data scientists. I don't know. When I was listing out like, because I listed out each platform and the things we solved and then the problems that emerged. And the total list of problems was like 30 or 40 different things. So I mean, like, if you want, we can talk about the 30 or 40 different things, because the next platform, I would think about all 40 of those. Like, anyway, Lineage is the latest one that I feel pretty strongly about, so. Guys, this is the author of the best-selling Manning book on LLMs.
Don't say anything like that. Okay, I'm really interested to hear your opinion, especially in front of a big group, about what is the best way that you have seen to educate data scientists on how to own their product, right? Instead of throwing it over the wall to the data engineers or the MLOps engineers. You know, how do you get these people who studied math like you or statistics to actually do the engineering?
Well, I mean, step 1, I think, is make the engineering as easy as possible, like as few degrees of freedom for like room for error as you possibly can. I don't know, because part of it's like an attitude issue. Like, you know, you get a lot of arrogant PhDs who are like, I can do anything, so like your engineering is beneath me. And like, I don't know that there's much you can do for like the attitude issue. But there are many who I think want to learn. Let's see. So I think just framing it as like the problem's not solved, and like maybe the most interesting part of the problem isn't solved until it's being used. Because like there's so many, like it's so interesting because like if you go buy a monitoring vendor, they'll help you track the F1 score of your model, but will they help you track the amount of dollars made by the model? You know, like that's kind of maybe the more important question. And it's like very interesting for a data scientist to start creatively thinking of ways to measure impact on the real world. And I think it's a healthy exercise because once they do, they're like the ultimate people to like QA their own stuff. Yeah, but
right, that's like what would you call that? That's a signifier of mature research, where it goes beyond the lab into the actual world.
I agree.
I'm just agreeing with you.
Sweet, yeah. It's been a fight always. There have always been people who didn't want to have like a minimum technical bar, like being able to use Git. And And I don't know, my most recent solution is just pick places to work where they already use Git. But we made a Udemy course, and I know people, it's made a difference for a lot of people. But they're the willing ones, so.
Just wanted to share a bit of my thought to that earlier question. Having been a manager that hire and build data science teams myself, and really emphasize with the epic fail one that you mentioned earlier, right? Definitely, we've been there, right? My teams have been there. Funny enough, and I've grown. I came out as a data scientist myself, and I find that a lot of data scientists actually a bit different from how you describe. And I think none of us are fall into one stereotype, right? But the ones that I've worked with actually they hate to stay on the same product for more than a year. They want to move on to the next problem. So I do think that behavior part, right, is something, especially as a manager, you have to be very aware of. Not forcing them to stay in that same thing for too long, right? So how do we do that, right? I do think that making ML engineering easier or ops easier for them helped. But one model that I've tried that I found useful was actually from day one, you form a squad that has an ML engineer and the data scientist together build that product. And then you allow that data scientist potentially to move on to a different thing, right? But hopefully you've educated your engineer to know enough about that product in the problem space to continue to monitor the product and then taking into more of a support model. And potentially even having to build another product support team somewhere else to really take over. So anyway, I'm also interested in others, what your experience is, because I have had sort of tried different models and definitely find different pros and cons.
I would love to talk more with you at some point later. This is totally the conversation I was hoping to have. I think we all sort of have ADD on the problems we work on. Everyone wants to do greenfield stuff and then not maintain. And I totally agree. I think we have software engineers who are interested in AI now. Before that, we had software engineers who were interested in data science. And I don't think data scientists, many of them felt comfortable not knowing how to deploy their own stuff. So I think everybody kind of the first 3 years of my career were spent figuring out how to run batch jobs on EC2, and now that's so easy because there's tools that make it easy. And I just AI maybe is making things easier, but just better tooling is also making things easier. And so I feel like it's sort of pushing all of us to have to be more end to end. I think we all like that anyway. So I love it.
Yeah, I was going to say that, also tying performance of data scientists to actual products will also help. So because we all work for money, right? So if at the end of the day, your performance is tied to the fact that your product or whatever is your data science output needs to actually see a customer use it and validate it, that would probably push either the data scientists to work more closely with the data engineers or become a data engineer or more data engineer aware.
Or burnout. Yeah. But but I agree with that though.
I have a thought on your question as well. I'm not with data scientists. I'm actually embedded with some semiconductor design engineers.
Oh, yeah.
But it's a similar paradigm where they're relatively good at writing scripts that do something and then throw it over the wall in some ways. And what I have learned, the difficult way, is if you're able to separate the concerns where it is easy for them to codify their expertise and they only need to know about their expertise, and you're able to take that into your system and do whatever needs to be done with it, they are very amenable to that. Because someone will move on to another thing after a year, but it's easy to slot another person in because it's in the same domain and they don't have to also learn Python decorators and dependency injection, right? They just don't need to know that stuff. So by constructing the system so that it's easy for the domain expert to inject their knowledge, it makes the whole thing much easier, even with over on the DevOps side. And to your point, ma'am, about having a data scientist embedded in the team, I can second that. Where it for us, I'm essentially embedded with a bunch of design engineers, and they are embedded with us. So it's like a war reporter in a way. So, but really, the separation of making it easy for the domain expert to declare their intent, whether it's code or YAML or a UI, whatever it is, that's so important. So that's my my battle scar.
My favorite environment I ever worked in, like right before the Ben Labs layoff, like we had just like sliced into cross-functional teams that were like led by the domain expert, and that was actually sick. Like it was so cool to work with some full stack devs, like because they made this beautiful UI that made our inference JSON like beautiful. But then we kind of had internal product market fit by default because of the domain lead, and it was a lot of fun to do that. Anyway, so.
Hey Eric, are you monitoring adoption of your data scientists?
Yes, we are absolutely spying on our users. Like we 100% are. So like we have like these internal SDKs, or when people use Metaflow, their username is attached to any flows they run, and like same with most of the pipeline tools. And so we definitely have. We're like sometimes we'll look at people's like Slack conversations and we'll count like the time like what features they may have asked about, or we'll see which features they've used in each of our SDKs. And man, that's like I mean. Everyone gets upset when your diagnostics for a failure goes out to Microsoft or goes out to Apple, but I mean, for an internal team, that is good info. Yeah.
So do you have like a dashboard for these proxy metrics, or?
I haven't gone that far, but I can like ad hoc query some stuff. But I mean, a dashboard would be cool. I mean, yeah.
What are like the rough edges with your current platform in terms of adoption? Like, what are they struggling with?
Right, it's fun, because right now our current platform is just all offline. I guess that's my other hot take, is like just stop doing online inference for everything you can. And we've been able to simplify to just all offline batch stuff. But like, the vendor we're using is awesome, but you know, there are regressions occasionally, and so that'll get in the way. Let's see. There's still kind of an overall learning curve, because we're asking like UV, Metaflow, VS Code, GitHub, like, so the learning curve taken together, I'm not sure what else we can do with that. But I want to make the iteration cycle times as quick as possible, so like once they learn the learning curve, like there's a huge reward. But I think if we were doing more online inference, like that's always harder for data scientists to grok. Another one is it's just more specific to our organization. Like we're using Snowflake today, but we're probably going to move off of Snowflake to like S3 and Iceberg, and that migration is probably going to be painful. We have people who want all of our data scientists to use PySpark instead of scikit-learn and TensorFlow and PyTorch, because one of the things PySpark gets you is like perfect data lineage for everything, but that's going to be really painful. So honestly, right now, my biggest pain point is just struggling to let our platform continue to exist. Like, because we touch a lot of cool use cases, like the ad spend one, or actually, that one actually doesn't use our platform, but a platform justifies its existence by the number of dollars theoretically being produced by projects on the platform. And I think that there's these internal politics where if there's another platform team, they'll actually try to absorb your customers and use cases out from under you. And that's like, I don't know, that's just common. That just is the nature of working in platform. Sweet, connect with me, and I'd love to meet, as many of you want to have deep conversations about this. So thanks a bunch for coming.